I am saying something.
You are the star of the show here. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Tom Nardi.
This is episode 316, Soft Robots, Linux the Hard Way, Cell Phones into SBCs, and the Circuit Graver. This week in the news, Tom was off partying all weekend.
It was a very long weekend for me, but, the sacrifices we make for Hackaday, right?
That's right.
Saturday, I was at the Vintage Computer Festival East in Wall, New Jersey. Always an excellent time if you're into seeing the origin of the species, as it were, for a lot of the tech that we take for granted. You know, I got to say, when I first started going, I would not have said I was like a vintage computer guy. But it's really very compelling, the kind of displays they do, and everybody is so eager to explain it to you. And, where else are you going to sit down and program, an actual Altair on the front panel, you know what I mean? And come away realizing, okay, well, this is what my phone does, but like a billion times faster. You know, it's a really cool experience that I would recommend for anyone in the area. And then on Sunday, I was at the Philadelphia Maker Faire, which was also a great time. I just actually today a little write-up went out for that. Some of the interesting things I saw. You know, it's impossible to cover everything at an event like this. I mean, there was so many exhibitors and just things to do and things to see. But I picked a couple of my favorites, and there's like a little bit of a photo gallery there. It's well, at least I often think about the World Maker Faire in New York going away, and as much as that sucks because that was kind of a totally unique experience to see all that stuff under one, not roof, but all that stuff in one park anyway. The fact that it went away did kind of leave room for these more localized maker fairs, and I think that's kind of like the silver lining, is that we lost the big one, but now it's given the chance for these smaller ones to flourish, and you get much more of just a local feel. It was kind of a uniquely Philly thing, like the venue and the people that were there and the exhibitors, and it's just a really good event. And they have, I think this is now like the maybe fourth or fifth year, I think. They started right before COVID. They had the unfortunate luck to start just months before COVID shut down. And, that kind of robbed them of a few years of momentum. But I'd say they definitely have found their stride now. And I'm really looking forward to 2026 and beyond for them.
I know what you mean about the impossibility of writing these things up, because when you see like 600 things that are cool, and some really click with you, some don't, whatever, but that's just too much.
I mean, it's a good problem to have, right? Too many cool things.
No, it makes for a great day. I love the post-apocalyptic, what is it, Waste World RC
toys
card things. Man, that is crazy.
His name's Brett, and he was just a cool dude. And I found myself like going back several times to his table, and he always had a group of people around, a lot of kids, as you'd imagine, were really into it. And he was just so happy to show off his stuff. And I think what impressed me the most is, I know for me, I would be terrified of anybody like touching these rolling works of art, knowing how much time he must have put into them. But
yeah,
for him, he was just like, here, take the controller, take the goggles, drive it around, do whatever. Like, he was just so eager to share it that he was, totally. I also thought about it later. I was like, this is probably a guy who loves nothing more than building these things. So if a kid crashes his car and he has to rebuild
he
it,
gets
like,
to build it again. Yeah.
Oh no, more time working on my models. So, but yeah, it was really. That one really stuck with me. And
for those of you at home, it's this visually stunning, like Mad Max remote control cars, but with FPV video cameras in them, and some of them are instrumented with screens, and it's just this crazy mix-up of like prop making, model making, tech, like the one with the workable game inside it. What?
That one's a good example. It has it's like a little tricked out station wagon, and the back it has this screen that's playing, I guess an NES emulator. But like, I don't think I mentioned it. The back door of that station wagon is on its own servo. So like, he flips a switch and the door opens automatically. Like everything is motorized, and you never knew what each thing was going to do. Like whether a guy was going to pop out or a rocket was going to launch, or like, there was another one of them. It had a literal flamethrower, although for the purposes of the event, he was not able to do that.
Too bad.
But yeah, they were really, really cool. And then, I asked him too. I was like, "Do you do this for like movies or like what is it?" And he said, "Nah, just just for fun."
No, it looks like it was awesome time. I totally dug that cardboard table saw too. Just picking random things out of your article. I had to go like try to figure out how that thing worked even. It looks like it's kind of a nibbler basically, but I don't understand that.
Yeah,
it's like a table saw format nibbler that is built especially for cutting cardboard. And so it cuts kind of a 5mm maybe wide swath in the cardboard, and it just like chomps it up as you go along. And so it's got a little cap on it, so it's entirely safe. Like there's no way to put your hand or your fingers in it, but yet it like just mows the cardboard down. And I was trying to figure out how does it do that in all directions at once?
Well, it's a cylinder in there, and there is a forward. Like if you notice on that little like mushroom top thing, there is like a white line that's like the direction it prefers. So you can't go backwards.
Okay, so you can't go fully backwards. Okay.
Right, you have some, angle in front of it that it's able to operate in, 180 degrees or whatever in that direction.
Okay. So it is a nibbler.
Yeah, and it makes a nice little, like, smooth, almost, it's interesting because when it makes that little bite move, it kind of like smushes the cardboard down a little bit, so it's almost like a cauterized wound. It's pretty
nice.
Yeah, it's pretty interesting.
As someone who absolutely loves building things out of cardboard, I was like, man, I maybe need one of these. And then I looked at the price tag, and I'm like, But he's like aiming them at schools and stuff.
Yeah. I think part of the price is that it has been like safety certified and stuff, so I know they did do like a lot of regulatory hoops that would maybe not have happened if it wasn't aimed for schools, but that's definitely a big part of it. I mean, you can put your hand right on the thing and it's never gonna hurt you.
I was looking at their Kickstarter. They have somebody trying to put their hair into it and get it tangled in there, and they're like just dangling their hair into it. I'm like, no. But it's fine. Anyway, I'm glad you had a good time, dude. And yeah, thanks for taking pictures of everything.
This is a journey into sound.
What's that sound?
What's that sound?
All right, this week is a sound reveal week, which means that last week Christina Panos listened to the sound and struck out, unfortunately. Let's see how you do.
Oh, I feel a little bit better. At least if I inevitably fail, I won't be alone. Oh, okay.
Thermal imaging, acoustic imaging.
I mean, it sounds like like a bellows or like a little steam engine or something. I imagine this tiny little train going around, but
nice. That's a good guess. That was a popular wrong guess.
A popular wrong guess. Okay, well, I'm on the right track of wrong.
Yep.
Someone was saying something about some imagery in the background. So is it some kind of transducer or something for ultrasound?
Mm-hmm. It has some kind of a sensor on it. Now I'm totally leading.
I don't know. I'll fold.
Printing press was my favorite wrong guess.
I could hear. Oh, sure.
And oh boy, do we have lots of wrong guesses. We have 48 people responded, and count them two, correctly guessed.
Wow.
That this is the sound of a Spot robot dog walking down a hallway.
Oh.
In a university context where I think it had some kind of LiDAR sensor on the top.
Oh, right. It's got some little
ultrasonic ranger.
Spinning thing on its head, right?
Yeah, but that's not the point. The point is it's that
okay.
Good. It sounds a lot like we got steam engine a whole bunch of times.
Oh yeah.
A bunch of different looms. Favorite wrong answers include Steve++, Large Hadron Collider, I have no idea what the Large Hadron Collider sounds like, but
Presumably something like this, but I
but
couldn't
now I'm
say.
going to have to go find out, right? Massive insecurity manufacturing germanium lenses.
Wow.
What? I have no idea how you got that one, but I love it anyway. Anyway, the nice thing about 2 is that I have to find a 2-sided die, and that's called a coin. So, Laser Kiwi, you get heads, and Jeff from Berlin, you get tails. Here goes. And it is heads. Congratulations, Laser Kiwi. A spot dog walking around. Doesn't get more correct than that. I'll get in touch with you and get your shirt size and send you a t-shirt.
AKA, this will be the sound of our nightmares in the future when the robot uprising begins.
Anyway, tune in next week for your chance to guess at a whole new sound. A brand new sound. An entirely different sound. Well, my first hack this week is a bit of a sleeper. I kind of read through it and I was like, whatever. And then I started watching the video and I'm like, ooh, this is really good work. And then I started looking at Soy Boy Soft's other work and it's really good. So if you want to dive deep into the world of soft robotics, you should start off with this post, Salamander Robot is Squishy, and then work your way through his back catalog of videos because they are all really great. I mean, I'll just cheat and tell you that in the first video of his series, he really kind of lays out the case for soft robotics and how it lets robots move things without smushing them and work in environments with people without destroying the people, without any of the complications of like compliant mechanisms and all this extra sensing and stuff, just because the things aren't dangerous. And I love that angle on it. But what really struck me about this is that he is working on a home fabrication method for making very complicated soft robots. And I guess soft robots is maybe a bit of a misnomer. Like they're half done in hard 3D printed plastic. So like he has a snake robot and the scales and the segments on the snake are of course hard plastic. But then in between he's got silicone kind of inflatable bidirectional knoppy muscle things. And that's what's making this all work. This video is the salamander robot. It's absolutely fantastic. It's got little pyramids for feet, and these are actuated by having 3 of these silicone bladder muscle things underneath them so they can move in all sorts of different directions, right? It's sitting on 3 of them, so you can move it left, right, up, and down. And then it's got 4 of these legs. And by sequencing the pressure to this cell, that cell, this cell, that cell, he can actually make the thing walk and dance and do all sorts of really cool looking gaits. And I thought that was pretty sweet. I think the build here is novel because there's a lot of making use of 3D printing. The body of the robot, it's all in one piece with a bunch of channels through to like route the air out to the little knoppy actuators on the end. And then the actuators are screwed onto it and sandwiched on there with yet another piece. It's just really a brilliant design and a really cool looking robot. And he minimizes the number of channels he has to do by having the front left leg and the back right leg always move the same. And so he can run the same air lines to the 3 different actuators on those 2 feet and vice versa on the other feet. He wants to make the thing have a waist in the middle, and I think that's his next project. If you want to see what kind of crazy stuff you can do with soft robotics, like I'd never really thought about it seriously. Like I do like those grippers, like the compliant grippers and stuff like that. I've always loved those. But this is like taking it to the next level.
I feel like we've seen, soft muscles and stuff before. They seem kind of almost like a proof of concept sort of thing, just like, okay, it curled up and it lifted a weight and that was fun. But, I don't usually see them moving across the table like this. And this is something where you can start to see, like a practical application. And the fact that this was done in the home is, I think, even more impressive. Like you said, like having those built-in channels and stuff, which are things that, I wouldn't say are necessarily impossible without a 3D printer, but certainly a hell of a lot easier to do that sort of thing than trying to like drill holes and make them match up. And I really like the bundle of hoses coming out the back of this thing. It gives it this very weird, I don't know. It reminds me like like a different type of robot dog that's gonna track me down and attack me. You know, it's got this like weird, almost biological thing. It's like an umbilical cord because I guess there's no actual valves or anything on the bot. It's all being done, you know, on the other side. You're just pushing the air into the different chambers you want to actuate. I think it's becoming easier to do this kind of stuff without a huge investment. I mean, what's it cost to get a decent printer that can handle flexible filaments these days, right? So
stop, because that's what I thought too. But the muscles are actually not 3D printed in there.
Oh, really? It's just the body?
Yeah, the muscles are silicone because they need to be like many, many, many cycles and very flexible. The muscles are actually silicone, but of course they're made in 3D printed molds. So, you know, you're not totally wrong either.
Yeah, you still need the printer, but okay, all right.
But that's another thing that's really cool about this, like just technique-wise, right? Is he needs a set of 3 of these like knoppy muscle actuators, and he can just make a mold that makes them all in one shot, right? And that's pretty cool. They actually have little almost suction cups at the ends of them. It's like a ball and socket joint almost. He plugs hard balls on the 3D printed part into the soft suction cup. So they actually kind of mate perfectly. It's really like some really awesome design work here. And of course, all of it done in 2 different steps, but all off the same CAD models, I guess. It definitely had me wanting to mix up some 2-part silicone and try to make some of these myself. Although you don't have to. On his first video, he starts off with one of those fidget toys with a bunch of little rubber knobs you can press in and press out. They're kind of bistable and come in lots of rows. I think kids fidget with these things.
I have many of them littered around my house from my daughter. Yeah.
Yeah, see, exactly. So what you do is you cut those up and you can use those as actuators, or at least he does in his first video, before he then decides to go on and add feet to them and make them into little walking soft robot legs, which is also pretty cool. At some point he mentions microfluidics, so I had to go dive into these old videos to see if he was using air or water here, but with those thin channels, I couldn't imagine that he was using water, and indeed he's not. It's all air. The first video, I think, has the beginnings anyway of his pneumatic setup, and it's a bunch of solenoids to open and close valves and a little, aquarium pump, basically, all of it run by an Arduino. And so that's what's kind of doing the sequencing. By this video, he's got something that can put out like 8 or 10 channels of air pressure and sequence it, which I think is really cool because that lets him play around with how the thing walks and stuff. What would stop me from playing around with this today is that I don't have a pneumatic sequencer, a computer-controlled pneumatic sequencer thing like this. And I'm like, wait a minute, this reminds me of the first prize in the 2021 Hackaday prize, which was a project called Flow.io, which was a complete ecosystem of these kind of pneumatic actuators and sequencers and stuff like that. And I, at the time, was like, it's pretty cool, but why did this win? And now I want one. So I was wrong. I think what I needed to see, and like you kind of said, like the Flow.io had a couple examples, but they were all kind of, they looked like examples. They didn't look like something cool that I wanted to build. Look, if you put pressure into this, you can make it bend this way, kind of demo, right? Like, and that's cool. But what's really cool about this video, like you said, is this is actually kind of walking and doing something, and it's obvious what it's doing, and it's interesting what it's doing, and that kind of makes you wanna dig into pneumatic robots, or at least me. So now I appreciate Flow.io.
There you go. They were ahead of their time.
I think absolutely. This is an active research area, right? Like, this is all the schools with robot programs are doing this sort of stuff. So it's kind of both simultaneously accessible and cutting edge in the robotics world right now. And I think that's also really fun. But this one totally took me by surprise. Like I was like, soft robot, meh. And then I just dug into it and dug into it and dug into it. Super.
My first one this week is 8 pins for Linux, and this one comes from Dmitry Grinberg. who has done a lot of work with weird little Linux devices, but this is the weirdest and the littlest one, I think. This is getting Linux to run on a trio of 8-pin hand solderable ICs, and actually, if you read it, the kind of the goal was, could he make a Linux like a Linux computer kit that would be assemblable by somebody who wasn't even experienced with soldering. He wanted this to be almost like my first soldering kit that just happens to boot Linux, which is a pretty serious goal. But spoilers, he pretty much pulled it off. I mean, we're talking about, like I said, there's 3 ICs, there's 5 or 6 passives. I mean, probably the hardest part to solder would be the S slot. It's got the finest pitch. It looks like something that should be blinking an LED rather than booting Linux. It almost is. It's hard to believe that there's enough here to run an operating system. Now, obviously, there's a lot of, it's qualified a little bit, right? I mean, you're not going to be running a browser or anything on here. This is a very, very slow machine. Although Dimitri does mention that it is fast enough to be interactive. So like you can pop open Vim and actually write something. You're not waiting for stuff to execute. It even talks about it has GCC on there and compiling simple programs if you've got a few minutes. The trick here is that there's got an ARM Cortex microcontroller that lacks the MMU that Linux would normally need, so it ends up still having to run an emulator. So even though the microcontroller is at 148 megahertz, what you end up getting is something closer to a tenth of that. There's also a problem. It uses SPI RAM that if I'm understanding this correctly, like the Linux kernel could not deal with that directly. So that's also why there has to be a layer of emulation, because the emulator is kind of, transparently talking to RAM, which would otherwise be inaccessible. But, you've got a serial port on there to hook it up to your computer, your real computer, to interact with it. You've got an SD card to put files on it. I mean, this is a fully functioning, albeit slow computer in an incredibly low number of components. And it was kind of made, like I said, as sort of a experiment in minimalism, but I feel like there's got to be some more practical applications for this. Now this is in the wild, and he's done a great job of documenting everything and how to assemble it and how to get it booting. I really hope to see this pop up somewhere. I think there's a lot of potential here for having that kind of software flexibility on such simple hardware. And yeah, I'm really looking forward to what the next evolution of this project is.
I love that you said it was slow, because Dmitry Grinberg is like one of the craziest gonzo hackers out there. It reminds me that, back in 2012, he had Linux running on an AVR Atmega 1284.
I suppose that's really slow.
And so I'm going to throw this link in there for you. And Brian Benshoff wrote this up, building the worst Linux PC ever. And what he means by worst is the thing only has 128K of flash. It's got a SIM card attached to it, and it's using that, and an SD card, I guess. But it runs at 6 kilohertz. Like, booting it up takes like hours. What does it say? 2 hours to boot to a bash prompt and 4 more hours to load up Ubuntu and log in. But it does. And that's the point, right? Like, you can get this running on an AVR. How much better can you do this on modern microcontrollers? And so to me, kind of the funny bit here is the time it does things is measured in minutes instead of hours, right? Like,
right.
It's not snappy, but
it's actually usable, yeah.
It's happening on a human time scale anyway, rather than on like the age of the oldest oak trees, which is it's pretty amazing how far we've come along. And again, as always, there are tons of problems solved and dead ends and clever solutions to these dead ends. And that's what I always love about Dimitri's write-ups, is they're just so incredibly detailed along the way too. And actually, Christoph picks this up in the comments, but it's absolutely worth mentioning. One of the tricks here is that with 8 pins, he doesn't have enough pins to do things. And so he multiplexes an SD card and a serial pin by having it toggle really fast for one of them and really slow for the other one, and then putting a filter in there so that it filters out the low frequency stuff or the high frequency stuff, depending. And so he can use one pin for two different purposes, depending on how fast he toggles it. That sort of kind of desperate but clever hack is just like, you wouldn't do that if you didn't need to. But now that you know you can, right? Like you could just you could double all of your output pins, right? Just put a low pass filter on it. And anyway, it's just a crazy, crazy hack. And, there's a million of these here. And this is totally worth your time to read it. It's every time Dimitri does something, it is full on. And it might take you an hour to read through this post if you do it seriously.
Yeah, I'm never going to complain about too much documentation. But I mean, he really does cover everything. And it's not just, the surface level, here's how it works in the completed sense, but there's a lot of talk about like why decisions were made and a lot of the background stuff that makes it. If you read this whole thing and you don't come away learning something, my hat's off to you, because you've got to be the grayest of beards to not be impressed by this.
It's not that I'm a slow reader. If I were just going to read it, it would take me 12 minutes. But if I'm going to read it and understand it, absolutely. You have to allow thinking time as well. All right, well, here's a palette cleanser. We'll go to something super simple on the opposite extreme, but nonetheless clever. Simple antenna makes for better ESP32C3 Wi-Fi. This is a sweet little antenna build by Peter Neufeld. I'd also want to point you to a previous one of his, and I'll talk about that before we're done. The basic problem here is that if you know the Seed Xiao, it's like a little ESP32C3 board with a USB-C plug on it, and it is tiny. And they're awesome because they're so small. Well, there's a whole bunch of horrible knockoffs of these that you can buy for kind of $1 on the internet. And a lot of them have, because they're cheap and they're not thinking, screwed up the radio section, and the antenna just doesn't work very well. And in fact, the antenna works so crappily that you should probably fix it up. And that's what Peter's doing here, is he is basically adding on an extra antenna to it. But you should see it because it's really clever. So there's like a little ceramic chip antenna on the thing. Some of the designs didn't cut out the copper underneath it, so it doesn't function. If you read the specs for it, which Peter did, it's actually supposed to have a strip line underneath it to serve as a back plane, and they didn't put that in there either. Like, half of these designs are just really crappy. They didn't even read the data sheet on the part. So Peter's fix is to make a little antenna that solders onto this chip antenna onto both sides of it. And one part of it is like a little semicircle. It's like a little C-clamp that kind of clamps onto it. And the other part is a quarter wavelength antenna that sticks straight up. And what the round part does is kind of serves as a counterpoise, as a base plane, as a ground plane for this quarter wave antenna that's formed by the little bit that sticks up. And again, this is 2.4 gigahertz. So, these things are all kind of, I don't know, I'm guessing it's like a centimeter long, but we could figure out what the wavelength of 2.4 centimeters is. This isn't the point. The point is, he gives you instructions for how to cut this and cut it to exactly the right size and put it on there. You could maybe trim it, I guess, later. You could maybe cut it a little bit long and trim it if you really, really want to match your antenna. But his suggestion is that you just build it to size, solder it on there, and he does the test. And, this is what sometimes is lacking in people building goofy antennas. I remember back in the old Cantenna day, people would just make crap out of Pringles cans and be like, well, it looks cool. It's got to help. Or now I get reception. That's got to help. But here he does the real test, which is to take them, a modified one and an unmodified one, side by side and figure out what the RSSI is across the room. And he does get a 6 to 10 decibel gain. So it's a lot better output on these. So for 10 minutes of work, you get an antenna that's actually kind of useful on these cheapest of all possible microcontroller boards. So that's pretty cool.
I don't know if you mentioned it, but my favorite part was that the little crappy ceramic antenna is still there. Like, you don't even have to bother taking it off. It's so inconsequential that you can still leave it there and just solder everything right to it. It's like a cross between like jewelry work and a microcontroller. It almost looks like you're meant to hang it like an earring with that little loop on there, but probably not recommended to hang your ESP by the antenna loop.
I wanted to make a new title for this one. I wanted to call it, improve your ESP32 with this one simple trick. Add an antenna. Because, like, of course you add an antenna if you're having problems with your crappy antenna. Like, it's the obvious thing to do. But what's cool here is that it's small and simple. And, if you're using one of these little Xiao form factor boards, you're using it because you want something small and you want something, that fits in a nice tiny space. And this is just like the simplest, smallest antenna. You don't have to deal with one of those, fancy micro connectors and then, pigtails and all that RF stuff. This is just solder it on to the existing bad antenna.
Yeah, well, I guess if you're starting from such a poor place, right, it's hard to get worse. Even if you introduce losses, it's like, well, it wasn't really doing much to begin with. So.
Touche. And that's the beauty here, is that I think the antenna doesn't even have to be all that good to be a significant improvement over like a badly designed one.
Maybe it's not fair to throw the antenna itself under the bus, right? I guess it's more of the way they implemented said antenna.
Absolutely.
So I suppose if you did it correctly, it would work fine.
RF engineers out there are going to get me on this one. I think there's no chip antenna that's as good as a appropriately sized piece of wire. At the end of the day, fair. I think there's always a little compromise there. But like you said, it's definitely good enough to get the job done if you just do the design right. Oh, but I wanted to talk about Peter's other antenna hack here. And this one goes a little bit further back in time. This is back from 2021. And he's got another ESP32 board where they screwed up the antenna application. And this is one of those that has the little folded F antenna. That's the one, you've seen those modules. It's got a little squiggly of copper off at the little tab up at the top. That's an F antenna. And you're supposed to keep that clear of the copper pore underneath. And if you fail to do that, of course, the antenna doesn't radiate right. And of course, there are some people who made ESP32 modules and they mounted the module over a copper plane, thus completely screwing up the antenna. And Peter's solution here is just so cute. He takes a little bit of insulated wire and he squiggles it up so that it follows the F's curly snake pattern, and he affixes it with hot glue and then puts a quarter wavelength stub hanging off the end of this. So this thing, like, capacitively, inductively, electromagnetically couples with the antenna that's on the module, and then, radiates that out of his quarter wavelength antenna stub that he puts off the end. Like, there's no cutting or soldering here. He's just bending a piece of wire to match the pattern on the board and then gluing it on it tight so that it couples to it and then radiates out the extra bit. I thought that was a super cute hack.
That's a proper RF wizardry.
That's a proper hack. And again, documented, he does the test with it and gets, again, another 6 to 10 decibels out of it, which, as you point out, is easy to do if they screw up the original one so bad. But nonetheless, for such a quick and easy hack, 10 decibels is a factor of, 6 is a factor of 2 or 4 in distance? I think it's a factor
2, right? Maybe
6 is double. It's double the power, so it's 4 times the voltage. If it's double the power, I think it's twice the distance. Yeah. So I think that's right. So I think he gets So I think, minimum you'll get double the range out of these, maybe even more.
And, you wonder, like, how did you make such a simple mistake in designing it? But I imagine, like, this thing is tested on, like, literal a bench test. Like, did it connect to the AP? Yeah, sure. Ship it. They're cranking these things out so quick. Nobody was worried about, can you get a signal at the end of the yard? They said, does the Wi-Fi work? Yeah, all right. Off it goes. Well, next up, I have Layer Lapse Simplifies 3D Printer Time-Lapse Shot. I'm sure we've all seen these really cool animations where a 3D print, magically rises from the bed and takes form, and there's no extruder blocking the view. It's just the printed piece itself. And a lot of times now that's done with Octoprint and a software plugin, which is fine. But, if all you want to do is take time-lapse shots and you aren't necessarily interested in all the other features of Octoprint, which is, admittedly an awesome project and you should check it out. This is a hardware solution that lets you do a similar trick. And really the trick is kind of 2 pieces. You want the extruder to get out of the way, right? You don't want the stupid extruder blocking half your shot. And you also need to trigger a camera when the object is in the same place, which is, I suppose, less of a concern on the newer Core XY machines. But if you've got a bed slinger, it's kind of important that the thing isn't moved every time you take a shot, because that's not going to make for a very nice animation. So this is it's a very simple little PCB that basically has a microcontroller on it, can hook up to your, proper adult camera, your DSLR, your mirrorless, as a remote trigger. And then it has a Hall effect sensor on another circuit board. And the idea is that Hall effect sensor would get mounted somewhere on the printer, somewhere on the frame that's within reach of the extruder itself, and then you put a little magnet on the extruder. So the last part of the puzzle is modification to the G-code that at the end of every layer, the extruder will move to this, particular place where the sensor is. The magnet will trigger the Hall effect sensor, which will in turn trigger the camera. You got your shot, and on you go. Obviously, this does add some overhead in terms of the print time, because you have to, move the extruder away, kind of stop everything for a second, take your shot. But, all in the name of impressing people on the internet. So it's a worthwhile endeavor. I really like this one because it's almost like an old school kind of hack in a way.
Yeah.
The software solutions through Octoprint are perfect. I mean, really. I mean, they work great. There's no downside to them. And but we're hardware hackers, and we do appreciate the occasional hardware hack, and that they can do all of this in just a handful of components and a microcontroller is really impressive. And there's also, there's like an extra GPIO pin that you can mess with. The firmware is open source, so you can do more than just taking a shot every layer. I actually wrote this one up, and I said in there, like, I'm not immediately sure what else you would do on every layer of a print, but there's really clever people in the community, and naturally, right in the comments, somebody said I'd like to have it fire off a bell at the end of every layer, so it's like a like a typewriter, like ding, and start the next layer. So it's available as a turnkey board that you can buy right now, but there are also instructions for building your own around your microcontroller of choice. So you have the option there of either letting somebody else do the hard work or paste it together. But either way, it still runs the same open source firmware. So it's a nice blend of DIY open source with a little commercial mixed in, and I think that's a cool way to do it.
Reading this one sent me off on an epic fingering through the back pages of Hackaday. I remember this one hack where the goal was to make a physical off switch to turn the printer off when it's done with a job. And the solution was to put the power strip on the top of the printer and then write some G-code that had it go all the way up to the top and physically press the switch. And if I remember correctly, it had like a pencil taped to the print head or something like that went up there and pressed this button. It turned itself off. And so it was kind of like the most useless machine where it like physically presses the switch and flips itself off. You could write this into your G-code at the end and have it go up and go click and turn it off. And for the life of me, I cannot find this link. So if anyone else can find this one for us, please leave it in the comments. It's the same idea, right? It's the same core idea to have it switch something by moving the print head over and doing it. This is just like fancy and maybe even more useful.
I think it's a badge of honor that we now have so many hacks that even we can't find the ones in the back catalog. We've 53,000 posts or something last time I looked. And it's, if you think it's easy to keep track of them all, I have news for you.
This fall, Hackaday is going to be turning 21. It's going to be old enough to drink finally.
It needs a drink.
Pour one out for Hackaday. Well, my last hack is what's kind of a product from a small company, looks like a engineer's passion project from Belgium called Citronics. And what they're doing is turning old cell phones into single board computers. And it's a really neat idea. I think I like it because, of course, I want us hackers to do it and open source it and make use of these old cell phones. Their demo dev kit takes a Fairphone 2, strips out its guts, and then it's got a PCB with cutouts for it and cutouts and connectors for it. And then, of course, all the peripheral attachment points you'd like from a Raspberry Pi-esque single board computer. I mean, it's got a 40-pin header. It's got 4 USBs. It's got an Ethernet. It's got everything broken out there so you can plug straight into this thing. And so you disassemble the phone, you pull the main board out, you plug it into this kind of daughter dev kit, proto board, single board computer thing, flash a Linux onto the device, and you are good to go. This one, I think they have running Alpine Linux, but I can imagine that there is a Linux flavor for a lot of old cell phones out there. And what I really liked about this one is that it's just a different and I think kind of refreshing view on the how do we reuse slash repurpose old cell phones. Because most of the time when I'm thinking about reusing old cell phones, I'm thinking about, well, what's a cell phone good for? Well, it's got this nice screen and it's got the touch sensor and it's got this camera. And all of those are actually done away with here. They don't use any of that stuff, which, on one hand is kind of sad. But on the other hand, if you're buying broken cell phones online, chances are very good that it's going to be the screen that's broken. And so that's the part you can't reuse anyway. And this kind of takes it and turns it into a small headless Linux computer with a bunch of convenient attachment points, right? Like, I mean, that's what's made us love single board computers. Everybody in the comments and myself as well have been thinking about, how would you do this at some other scale? In some sense, they're kind of cheating by picking the Faire phone because the Faire phone's meant to run Linux. It's meant to have its motherboards be interchangeable. And, it was kind of built to be a almost modular, but certainly more user serviceable phone. So they are kind of picking the lowest hanging fruit here. On the other hand, if this was how you were starting off, that's how you'd start off. It totally makes sense to me. A lot of people in the comments point out that you'd have to have a different breakout board for every phone model out there. And I think that's true. And I think the goal of I want to make a universal breakout board that works with every cell phone is, of course, completely impossible. I think if you start with that as your goal, you will get absolutely nowhere. Whereas what they're doing here, I think, is actually really smart. They're saying, here, we'll take the easiest phone to take apart and do this with, and we'll do it. And I want to see someone do it with maybe the next easiest phone, something, that is easy to find broken or used or with a dead battery on eBay for $5 and just pick that one. A phone that's got, maybe a good power versus speed characteristic and, runs Linux, of course. But the nice thing is it doesn't need to be fully supported because it doesn't need to have the screen driver work and the camera driver. And I know from running alternative operating systems on cell phones that it's like the cameras. There's never mainline Linux support for the cameras on random cell phones. And so getting that working, is super hard. If you do this with it, you don't have to get that working and you've still got something useful out of the phone. I think it'd be really cool. And my guess is that that a lot of the hard part of doing this is figuring out the connectors that come off of the motherboard and the phone and doing that kind of reverse engineering. But once you've done that once or twice, it's probably easier to do for, arbitrary phone models. And I think that may be what this company's betting on, is that by practicing doing this, they're going to get good at it and be able to make, custom small computers out of arbitrary reused cell phones for their clients. And I like that idea. I think it's really clever.
Well, it's funny you mentioned that. The screen is probably going to be broken. It reminds me, my wife recently somehow broke the screen on her phone. She claims she didn't drop it, but we won't talk about that.
It just happened.
I don't know. It was in my bag. It just happened. But I told her, I was like, okay, we'll get the new phone. But I was like, that one's mine now. I want to use it. And she looked at me like I was crazy. She's like, what are you going to do with a phone that the screen doesn't work? And I was like, where we're going, we don't need screens,
That's right.
Because there is so much you can still do with it. And the screen, even if you don't modify it in any way, you could use it as a camera or, like a webcam or something. You could do. Today, we ran a post about somebody installing Postmarket OS on a phone as is and using it for a server. You don't really need to do anything if you're just trying to, like in the write-up. As long as you're happy with the USB port and the Wi-Fi that you get on the phone, You don't really need to take it apart at all, but it is a little limiting in that way. You know, you're talking about if you don't want to do a software thing, if you don't want to host a web page or whatever, if you want to do anything more advanced than that, then yeah, it would be nice to break out more of these connections. And you know, to that end, yeah, it probably is. I would say it's definitely impossible to make like a universal one that works on every phone, but there are, you know, certain phones that are way more popular than others too, right? So I could see like the next step would potentially be like, you know, one of the Pixel phones, or I mean, maybe even one of the you know, like the Nexus 5 or something. I mean, you can get those for a song on eBay, and they still got enough oomph to do something. And then maybe even potentially like Samsung's Galaxies. You know, I guess by the numbers, there's more of them probably than any other Android device. So, you know, I don't think we'll ever get like the universal plug and play board, but I could certainly see the A-listers, for lack of a better word, right? Like they could have their own little breakouts, and even that would be a huge improvement over the nothing we have now, realistically. But you know, this is something we've talked about so many times, like the crime of not reusing these phones. And I mean, we're talking about billions of perfectly serviceable Linux machines that are just sitting in drawers because the new hotness came out. And I think we're kind of all guilty of it. I mean, I know I have plenty of cell phones sitting in drawers that, you know, could be repurposed. So anything that makes that easier is definitely a win. But it's tricky from a hardware and a software perspective, because, you know, so many of the phones are locked down and that kind of thing too, and that's a bummer. But I mean, that's going to have to change, I think, on the manufacturer side. You know, and maybe that's the push too. I mean, maybe we can guilt some of these manufacturers into say like, hey, like there's a market here to reuse these and do other things with them and keep them out of a landfill. But I can't, because you locked the bootloader down, and I can't put a different Linux on there. So you know, I don't know. I'd love to see a future where every phone at the end of its life could be some little server sitting on a shelf. But we're getting there. We're not quite there yet. But at least we're moving the needle in the right direction with projects like this.
What you said about picking the phone model and then just using that, I think is the way to go. And if you think about, you know, how many hundreds of thousands, millions of Samsung S3s are there out there? But like, you could just pick a model, one arbitrary model, and maybe it's a good idea to pick an old model like that, because maybe the connectors are easier to interface with. I don't really know. But if you did, and if it became a project that was so popular that every hacker wanted to have one, or every hacker wanted to have 10, or there's still enough of them out there on the market. Like, it's not like you have to diversify across models because you're going to dry up the supply of old cell phones. The supply of old cell phones is infinite. It's you know,
yeah, realistically, yeah.
We're swimming in them for the rest of our lives and then some. So go nuts. Just pick any one, but maybe especially a successful one, like you say, one that sold a lot of, and go to it.
I guess devil's advocate here. Like, as cool as this is, these like breakout boards, you know, I do wonder, would a more practical solution simply be like a USB breakout? You know what I mean? Something that you could just plug into the phone's USB port, and you have the Ethernet, and you have some chip to give you a GPIO, and you know what I mean? Like, and then you could just take the phones as they are. You don't have to strip them down. You just plug it into this thing, and as long as it's supported by, like in this case, post-market OS, or, you know, I mean, that's probably a lot more practical, you know, making some kind of like, you know, just an IO expansion thing over USB. And, you know, now that I'm talking about it, didn't Google at one point actually propose something like that? Didn't they have some?
Yeah, that's the IO board or whatever they called it. Project was a failure in the end. I guess nobody used them. I think they were like ridiculously expensive.
So maybe, you know, the answer could just be like an open hardware, low cost thing you can plug in and get all those expansions without having to crack the phone open, you know?
The USB solution, of course, is the universal solution.
Right.
Every phone's got
it's right in the
every
name.
phone's got a USB plug on it. It turns what is here a hardware problem into a software problem. And I think, I don't know, for me, the software problem is the problem with reusing cell phones. I don't want to use Android. I don't want to write stuff in Java.
Right. You still need to put something else on there.
Yeah, I like your idea too. Happy with either of them as long as it gets those cell phones out there and used.
Yeah, right. I can't for the life of me actually find that Google thing.
It's called IO, 2 IOs in it. Pronounced yo-yo. Oh, my bad.
14 years ago they came out, man.
Oh,
it was
first
made by
manufactured by
SparkFun.
SparkFun.
Yeah, that's
You
interesting.
go. Here, I'll throw the links in for y'all.
According to Wikipedia, the IOIO board is entirely open source, so that's interesting.
Oh, sure.
We could see somebody doing a modern clone
Oh, there you go. They wanted $40 for it. Yeah.
for $2 worth of components.
Touche.
Well, my last one is Ben Eater versus Microsoft Basic, and this has been going on for some time. This is like a 3-video series. I think the first video might be like a year old, but the most recent one's only a couple months old. And this is about, well, obviously Ben Eater's 6502 breadboard computer, which I'm sure anyone listening to this is well aware of, and maybe even has one running on the shelf next to him. The effort to bring MS Basic to it, and in Ben's classic way, like, it's just a phenomenal series of videos that starts with, sort of like, how do you get Basic running in the first place? What does that look like? What is it like porting that to a new system? Just at a very general hello world. You want the interpreter to start and understand the hardware, right? So that's its own video, which, if you're doing any kind of like your custom homebrew computer, that's probably going to be of value to you to watch. After that, it goes more into the customizations necessary for Ben's specific machine, which has like an LCD display hanging on it and the trappings of being a breadboard computer. So he kind of drills down a little bit more into those modifications, up to even adding a new basic command called LCD print, which lets him, surprise, print to the LCD. It's a rabbit hole, right? And I'm certainly not alone, I think, in just being supremely impressed with how Ben does these videos and just the polish put onto them. And I wish... Like when I watch one of his videos, I'm like, oh yeah, this is what YouTube is for. Sometimes I find myself kind of jaded by some of these YouTube celebrities, let's say, and the way they portray their projects at this very surface level. And then you have somebody like Ben, who shows, okay, like, yeah, this is a very valid way of showing things off if you put the effort in and you do it well. So I mean, I can't recommend his stuff enough. If you are somehow not familiar with his incredible series of building this breadboard computer and now running software on top of it, like, this is definitely a must watch. Kind of like going back to what I said about the Vintage Computer Festival thing. Like, before I had watched these videos, I would not have said I was interested in this kind of thing. But I mean, he makes it so compelling and brings it to a level. Just watch them. just watch these videos. I can't. It's impossible to say too many good things about Ben's videos, and there's just so much to learn. And like my daughter, my oldest, she actually came to me with one of the Vintage Computer Festivals, and she sort of like, oh, that's interesting about, how the computer actually works at a low level. And I was like, all right, well, like, check out some of these videos and you'll get it. And she did. So it's definitely worth checking out. And I think it was also interesting that apparently this tip came in courtesy Mark Stevens, who saw the Altair Basic post that went out last week. That was Bill Gates, his first-hand account of porting Basic to the Altair. And having seen Bill Gates, his write-up, and Ben Eater's, Ben definitely wins for the more interesting write-up of bringing Basic to a new piece of hardware. To be fair, I don't think Bill was trying to put that much technical detail into his coverage of the event.
Oh, that's brutal. Yeah, I think what's fun about this is that when he does his breadboard computer things, it's kind of demystifying a bunch of the hardware, and this is kind of going into the software side of things.
Right.
It kind of makes you appreciate how hard these old languages were, how interesting it is to write an interactive interpreter that then does things on the machine language level on your behalf when you type in, English language words. It's something that everybody should do if you've ever used a programming language. It's kind of nice to see how it works under the hood.
Yeah, it's the stuff we take for granted, really.
Right?
It's all just done. It's all like hand wavy magic now. And I mean, I guess that's fine, right? Because you can't be banging rocks together forever, and the modern development tools are basically magic. But I think there's a value, and we've said this, many times, that there's a value in understanding the fundamentals, and it's just like you can't master it any more than that, right? Like you've defeated the machine. You understand it at its most basic level. Short of seeing how the electrons are spinning around in there, you have it all in your head.
My first quick hack comes from Decorus, a tiny tape synth. He calls it the tape organ. He's basically taking apart a tape player, building a nice little 3D printed insert so that it can run a tape loop, and then playing it back at speeds controlled by a microcontroller responding to MIDI so it can play different notes. He's got a little looped sustained note on there and it's playing different pitches. He's going to make 3 of them so he can play music with a little bit of polyphony. I'm looking forward to seeing it. Cloud Compare is a point cloud software that Donald Papp brought up in this article. If you're 3D scanning, you want to work with point clouds. And it looks like it's a great solution to what happens if you scan something, you just get a whole bunch of points. If you want to then model it and print it or work with it, you have to turn it into triangles or something. That is one of the features that Cloud Compare does. It also lets you merge different point clouds, so it figures out where they have common features, and that's what the quote compare part of Cloud Compare is about. Lets you put different point clouds together and then make a surface out of those. Comments of the week on this one, as far as I'm concerned. HD came in with this comment. As a forensic dentist, I've been using Cloud Compare for several years to solve bite mark cases. You take a scan of the person's mouth, you take a scan of the bites on the victim, and it puts them together. I think that's fantastic. Only in the Hackaday comment section. And last up, quiescent current. Why USB-C splitters can cause magic smoke release. I didn't know that there were USB-C splitters, but I guess if you want to charge your phone and then run some other device at the same time off of one USB-C wall wart, this is one way to do it. The problem, of course, is that USB-C has all of these other fancy power delivery modes, including ones that for a lot of cell phones these days request higher voltages so that they can charge faster. And so it doesn't have to run as much current because it gets the power across by raising the voltage up. If the thing that's also plugged into this doesn't want to deal with having 20 volts, 48 volts even these days, it could end up poorly. And his particular nightmare scenario is if you're charging your phone and a power bank at the same time, your phone requests 24 volts and the power bank is expecting 5, and you catch the lithium ions on fire. Totally plausible solution. I don't think you should have a USB-C splitter.
Probably the right conclusion.
It's not just wires anymore. It's wires plus brains. And when you add the brains in, you can't just cut them in half and send them in 2 different places.
My first quick hack is tracking the ISS made easy. We've seen a lot of the products of this before where it's a little pointer that will spin around and aim at where the International Space Station or whatever celestial object happens to be moving overhead. I really like this one in particular, though. Farid Rainier actually goes into a little bit like the math of figuring out how to take what they call a 2-line element and do the algorithm to figure out where it's going to be. Whereas I feel like a lot of the other projects we've seen have kind of just taken the easy way out and used some Python library or pulled it from the internet. And I appreciate this one is actually doing the calculations right on the microcontroller. Nice change of pace compared to some of the other ones we've seen. Next up is Command and Conquer, ported to the Pi Pico 2. This one is a little bit of a bait and switch. It's technically the RP2350, but it's the Pi Moroni's variant of the Pico 2, which adds 8 megabytes of PS RAM and 16 megabytes of flash compared to the standard Raspberry Pi Pico 2. And that's necessary to get the game running because it's stuff that would normally have been in system memory has to be pulled from the flash and from an SD card. There's not a whole lot of information in the GitHub repo on how to actually get it running, but there's a series of videos where Charlie Burks, the guy working on this, shows it, and it looks pretty good to me. It looks like it'll be an interesting project when it's all said and done, and just an interesting reminder of how powerful these microcontrollers are now that they're playing PC games from the mid '90s without too much of a sweat. And finally, Fiber Laser gives DIY PCBs a professional finish. This is a post from Mikey Sklar that's actually sort of a continuation of a series he's been doing where he's making some very professional looking PCBs on home hardware. He started with just the earlier videos where etching the board and getting the the traces down, and that's a big part of the battle in making your own PCB. But these etched boards are exposed copper, and they're a little finicky, and they could benefit from having an actual solder mask on them, and if you can swing it silkscreen so that you'll know what parts go where, which is kind of nice. In this video, he shows applying a UV solder mask and curing that, and then putting the board into a fiber laser, which is used to first blow away the solder mask where all the pads are and expose that, but then also embeds the silkscreen art right into the solder mask, and it really looks phenomenal. I think the biggest surprise for me is even though it's just lasering into the UV cured solder mask, it really looks like it's white sprayed on text. It's kind of a surprise how crisp it all comes out, and the end result is it's not a perfect board, but it's very impressive for something that was made at home. The downside is you're spending several thousands of dollars on the necessary equipment, but hey, it'll get cheaper as time goes on.
All right, well, it's time for our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week I picked Jenny List's Which Browser Should I Use in 2025? That's fun because Jenny has taken a look at some alternative browsers before, and in this one she used writing up the article as an excuse to check out as many free and open browsers as she possibly could, and does a good job at it. Her starting point here is kind of dissatisfaction with the browser ecosystem. 10 years ago, there used to be 3 or 4 browsers out there, and now it's really just down to Google's Chrome and maybe Firefox around the edges. Like Safari's dead, Internet Explorer isn't a thing anymore. They've all kind of packed up and gone. There's really kind of 2. And Firefox seems to be A, fading out, but B, as she points, fleeing to the dark side in pushing ads on you. But if Firefox is fleeing to the dark side, Google's Chrome is the dark side. Anyway, don't get me started. The point is, can we do other things? Can we get diversity in the browser ecosystem? And the answer is kinda. What she finds is that a lot of these browsers use the same rendering engines, even if they're different browsers. But maybe that's a good thing, and we'll have to talk about that a little bit. Apple used to have their browser engine called WebKit, and that, I guess, is used by a couple of these alternate browsers. But most of them use the Google Blink/Chromium engine and the Mozilla Firefox Gecko/open source Goanna fork as their basis. And so what that means is that you've got kind of the guts of the 2 big player web browsers out there, and then it's just what does this particular open source software bring on top of that? And so that means on one hand, there's probably not all that much difference between them. On the other hand, you can pick and choose among different functional browsers that do one particular niche thing you want or another. So yeah, they're all the same, but there are small differences. In the end, she tries them all and kind of ends up on LibreWolf, because it's basically Firefox without Firefox running behind it, and Vivaldi because it feels a lot like the early Opera browsers. And if you played around with Opera back when it was the brand new upstart, it was actually really fun. But it's also based on the current Chrome engines. So it's a lot like Chrome. And those are her two picks. I actually have my own favorite, which is no surprise. I like to use one called Qt Browser, which is entirely written in Python, runs on Qt Web Engine, which is, of course, based on Chromium, which I guess makes it a Blink family browser. The weird thing that one does is it runs everything on the keyboard, so you never have to pick your fingers up off the keyboard. So you follow links by pressing F, and then it highlights all the links with different letter combos on them, and then you type in like AD and it follows that link, or you type in JK and it follows that link. It's kind of fun. I don't know. I don't like to mouse around too much. It's just preference. Do what you want. But I think that's maybe the point here is that when you have a couple big web rendering engines like these that are, I guess, hackable and open source software projects can spin off on them, you can kind of get a weird variety of user experiences in the browser. Like she liked Opera, and so she gets an Opera-like that runs on a modern rendering engine. I like Vim and not picking my hands up off the keyboard, so I get Qt Browser, which also is the same. And Scriptable. Did I mention Scriptable? Different browser flavors that are kind of all the same thing, but then have these little bitty different user engine experiences or better privacy than some of the mainstream ones. And I actually do think that's really neat. So I guess what came out of this to me is not as much, which browser should I use, as much as, oh, hey, look, there's all this cool variety out there, even though it's kind of almost a monoculture, even though Blink has basically taken over and the Firefoxy, Mozilla ones are kind of a second role these days. The privacy and user features aspect of them is quite variable. And there's more variety going on out there than we thought.
Well, I appreciate this article. I think it's very timely. I think it helps answer questions that a lot of people are having. There is certainly a migration of sorts from Google's browsers, and like I said, Firefox has its own problems. I am somewhat ashamed to admit, though, that I just use Google's browsers. I do try to stick with Chromium, the open source version of Chrome, but I mean, even I'm guilty of using Chrome on occasions myself. But, I can see why. There's obviously a need for competition, and it's good to see that it's still out there. It's not a complete one-sided situation, although it's perhaps closer than we would like. It's funny to think that Chrome was started to keep, Microsoft from having basically a monopoly on the browsers. And here we are, however many years later, where Google is the one that, ultimately got the very near monopoly. So live long enough to be the villain or whatever. And they've certainly come full circle. As for like Firefox, I mean, I think I was also on the Firefox bandwagon when it first came out, when it was basically either Internet Explorer or Firefox was kind of like the big debate of the day. I don't know. Modern Firefox just seems to bother me for some reason. I don't know what it is exactly about it. I don't know if it's just the Linux builds are slower. It just feels kind of slow and clunky to me. It feels like it hasn't changed.
Feels sluggy and bloated somehow. Yeah. I don't know if it's true.
Right, it could just be a perception, but it seems like it hasn't changed in like 20 years, and I don't know. Maybe it's time I do take a look at some of these other browsers, and I will definitely be following along in Jenny's footsteps and looking at some of the ones that she recommended here. That is certainly the beauty of open source, and that we have these choices, and we can, even if it's not, not a choice that's ever going to be for the mainstream, like we talked about. Like I honestly, LibreWolf, I never even heard of that before this article, but I'll give it a shot now, right? So I would advise anybody else who has kind of been on the fence about the way things are going with Google and, blocking their attempts to keep ad block and stuff from working. If there was a time to look at the options, this is probably it.
The one thing that bums me out about it is that, every once in a while I'll load up a web page these days and it won't run on one flavor of browser or another, and I have to fire up a different one. And that's just so intensely frustrating. And Google does seem to be doing this right now. They seem to be just implementing a lot of their own stuff and calling it standard because they can. And so if like you try to do, my bank won't open up on Firefox. I have to pull that one up in Chromium, which again, it's no problem for me, but I'll just pull up Chromium. I have 4 or 5 browsers installed. I have my preferences, but Google Meetings doesn't work with Qt browser as well. It only works with Chromium and my hardware audio interface. It's just dumb things like that are frustrating still. And it's kind of funny that, given that they're all using the same rendering engine and deep down, how's it possible that we're here again where some web pages will work in one browser and not in another? And historically, there was this great problem back in the early 2000s, and then we kind of solved it by enforcing standards on all the browsers. And now that Google's dominant, they're like, we make the standards.
I think one of the big ones for me is like the web USB stuff that is becoming so popular. I mean, like you want to flash a Mestastic device or use a Betaflight on a drone. Just being able to plug it in and from a browser tab interface with it is awesome. And I guess
it's hella cool.
Mozilla still doesn't want to embrace that. They have they say, okay, it's a security thing, which I get, but I mean it's also extremely handy for interfacing with devices and seems to only becoming more popular. So yeah, I think at some point they're going to have to maybe bend the knee on that one. And
I think they probably should.
Yeah, but just like you said, there are still things that, even if you're using these alternative browsers, don't be surprised if you're like, oh, wow, I think I still need to get Chrome from the mothership.
Just install one of each and use them.
Yeah, right.
I mean, like, don't worry about it. It's not a big deal.
Yeah, we have terabyte hard drives now. We don't need to worry about it. I have all the browsers installed, really. My pick for Can't Miss is Lewin Day's write-up for SuperCon 2024 talk. Quick high-feature boards with the circuit graver. And I actually missed this entirely when I was at SuperCon. If you've never been, or even if you have been, you'll even know more. It's like drinking from the fire hose. There's a lot happening in a very short amount of time, and doubly so if you're, kind of behind the scenes trying to help things along. So I was very excited to finally see this talk. Quality, easy home PCBs have been kind of this holy grail for as long as electronics have been a hobby. And it's always been, you had the toner transfer and nasty chemicals, and that, fine, okay. And then now we have CNCs, and we can engrave them, but they're not ideal because they make a bunch of dust and they're fiddly. And now you got lasers, but the lasers can be expensive. I mean, none of them have been really ideal, and they've all been significant hoop jumping and usually a lot of upfront cost. And this has been at odds with the fact that it's been cheaper than ever to get PCBs made. That may be changing due to political things we won't get into. So I think there is maybe more than there has been in the last few years an interest in, how can I make these boards at home? At the very least, those early prototypes that probably aren't going to be 100% anyway. Can I not send those offshore? And this is a new entry into the options. This is from Zach Friedland, and it carves the traces into a copper-clad board with a sharp little knife that was actually, I think, was really for like a lathe. And what was really interesting in watching the video is that Zach says, like, originally he did this by hand. If he had a simple circuit board, he would actually just get the little blade and like whittle it like a wooden duck, and he would just cut the traces out. And he said, well, hey, if I could do that, if I could do it by hand, certainly I can make some kind of a motion control system that would move this blade around and put the appropriate pressure on there. And what I thought was fascinating is apparently this is like an idea he's had like banging around in his head for a while. And then when we did the call for proposals for SuperCon, he was like, you know what, I'm gonna really do it and put it together in that amount of time. It was still kind of like this concept when he put the idea in, and he used the SuperCon as like nothing like a deadline, right, to to get you motivated. So that got him building this thing, and it's really fascinating to watch it in operation. It has like this little blade, and it spins it around, and it makes these cuts, and it's a V-shaped blade, so it goes right through the copper into the substrate. You have a nice isolation for the traces. it can't get super tight right now. There's a limitation to the taper of the tool. He's already sharpening the tool more than it was originally, but it's enough to do. He demonstrates like 0804 resistors and some 0402 LEDs. So I mean, that's pretty impressive for a home machine. Certainly for prototypes. What I thought was interesting is that, and this is something that I kind of saw too when I was trying to make my own boards on like a diode laser. It seems like the boards that he has for this thing tend to have very straight and simple traces, and they might not be the kind of traces you'd use if they were being professionally manufactured. So like part of it is having the machine that can engrave these boards, but the other half is maybe being a little mindful when you're designing the board itself and you're doing your layout. Like let's try not to give the machine a harder time than it needs to be. Like try to keep the traces straight and give yourself enough space. But I think that's still a valid trade-off for like a prototype board, because I always think that, at least for me, I think I screw up in the schematic part of it electrically more often than I do the actual layout. So like I think there's value in being able to say, hey, here's my schematic. Here's a simplified routing of the board. Can I make sure everything works electrically and at least get those gremlins out? And then you can go and do a more compact routing for the board you send off. So I think it's a fascinating machine. Offers a lot of potential, and like I said, it could be that we're going to start seeing people more interested in doing their own boards again. And if you don't want to spend the thousands on a fiber laser, or you don't want to spend the time fiddling with a CNC that was really never meant for this kind of fine work, this could be the option you're looking for.
It's just a lovely machine, and I just love the way it works. Like you said, it cuts with a head from a lathe, but that's been super sharpened so that it's really thin. But that also means that it has to be cutting in the right direction. So it's actually a 4-axis machine. It's got X, Y, Z, and then it rotates this lathe head around, so it's always cutting facing the right direction. And that makes for a really interesting motion control problem. Like there's the whole, how do I make the paths for this in this kind of 4D computer-aided manufacture problem that he's got. And it's really neat. The Z is, of course, only kind of Z. Like he doesn't go up and down a lot. It's either cutting or it's not. But still, when he starts a cut, it kind of slowly, incrementally digs down to depth. So he has to kind of turn around at the end and like lift up, and it's got all these funny dances that it has to do. It's really cool. I love the fact that he chose to kind of handicap himself when he was making this machine by saying, I'm not going to do this at work where I have all of this crazy fab equipment. I'm going to do this instead at home, and I'm going to do it with things that the average home gamer has because I want them to be able to recreate this. And that means a lot of it is 3D printed. And I think he has only one part manufactured, and it's a small aluminum piece up in the top of the Z-axis. But the rest of it is just this like chonky 3D prints with flexures in it, and it's a really awesome machine. And then like you mentioned, doing the programming for it, the board layout versus the how do you cut these traces. It's like you're not even cutting the traces. You're cutting the isolation lines in between the traces. Right. So in some way, you have to kind of rethink the whole board design. Like you have to think about the negative space, not the wires. Or at least it does in its path planning phase. And that bit's also really interesting. I mean, we think of laying down wires, but this thing is really where are the dividing lines between sections of the board that are electrically equivalent. And that's just a different kind of way of thinking out the layout problem. So there's a lot of stuff, I think, left to do on the software side here. And he has a collaborator who's really interested in both the 4D motion control aspect and the path planning as well. So, super cool to have a smart and involved collaborator who happens to be working on their thesis on exactly this topic. Anyway, this is a really sweet project, and when I need to make a stupid little breakout board, I will actually grab for a mat knife and a blank piece of copper. I do this all the time, just, in the old monkey with his sticks and his rocks sort of way, not with the I have a sweet machine doing it. And so I totally appreciate, just the simplicity of cutting the lines yourself. When you really just need something that's a little, SMT to pinhead or breakout board, and you can just cut the isolation things yourself. Put a Sharpie down, scribe it on there, and then cut them. It's not a problem. Get it done quick. Fancier boards, I'll do toner transfer or I'll get them ordered. And it all depends on how impatient I am. And I think that's the other thing that's really cool about this. People who have PCB mills and use them a lot also find this to be the case. That it's just getting you the part you need right now and not taking you out of the flow for ordering and delivery and, all of that other stuff that comes with getting the board professionally manufactured. Especially if you got to get this project done this weekend, you only have, because you have a day job, you only have a day or of free time to screw around on this. You can't afford to wait for the board to come in. It's much nicer to just bang something out now and get on to the next stage of the project. And so in that sense, I think this is a tremendously liberating machine. I think that's kind of what Zach is aiming at here. Just a thing that lets you get the quick prototype made as fast as you can, get on to the next part of your project.
Just a little bit ago, we were talking about putting solder mask and silk screen on a board with a fiber laser that, costs as much as a used car. And that's all cool, but for my money, I think I'd rather have something that can knock out an ugly but totally functional prototype board than something that is, making quote unquote professional looking board, because you're never going to do as good as the board houses. That final step is always going to be let me send this out, especially if you're making, 100 of them, right?
Yeah.
So, I think a machine like this that, there's obvious trade-offs and, it's not going to necessarily be something you're showing off or even using more. I mean, it could just, you like you said, do a breakout or something, or you just want to test out some new chip and it might be used for an hour and then you throw it away. I think this is, got a lot of potential for that kind of thing. And I think that's in a world where boards can be made, cheaply and pretty quickly, but you still want to have that prototyping flow. I think this makes more sense than trying to replicate a professional board. You know what I mean? I think that, the end goal has changed a little bit. Now that we have such good options for making pro boards, we need good options for making less pro boards, if that makes sense. And I'm really excited to see where this goes. And, just another option, one of them problems that seems to have many solutions. Could finally be the one that we've been waiting for. Plus, you get little copper ribbons at no extra charge while you use it too. So if you have an application for tiny little copper curly cues,
decorate your Christmas tree.
Yeah. If you need tinsel, I'd rather have that than copper dust from the CNC, obliterating it, right? So.
You'd rather have that than the epoxy dust. That stuff's straight up carcinogenic. You actually really have to think about that if you're doing PCB milling in any scale at home. Don't get that stuff in your lungs, folks.
Yeah, this is much. I mean, for nothing else, it's much neater and cleaner than other subtractive methods,
and quieter and faster, and yeah.
Who would have thought the hand method would be, the most efficient compared to brute force mechanical spinning tools?
Zach Frieden is a Hackaday super friend. He was actually at Super Conference #1, and this is 10 years later that he finally gave his second talk. He's smart. He's funny. It's a great talk. Aside from the machine, you should just go see it. It's really sweet. Don't be a stranger, Zach. Give us another talk before another decade goes by. Of the absolute best, I laughed out loud and had to explain it to my wife when Zach in this talk says that he saw that the deadline went by and then he saw that we extended the deadline and he decided, okay, that's it, I'll apply. And secret behind the scenes info, we extend it every time because we know you people do that. And I'm so happy that I Jedi mind trick Zach into doing this project and giving a talk on it.
We know you do it because we do it too.
Yeah, well, yeah, exactly. How many times am I so angry at myself for having missed the deadline by one day? And then how happy are you to find out that the deadline, you haven't missed it and you can do it? Works every time. Reeling them in like fish. Well, that wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you have something you want us to cover, send us a tip, tips@hackaday.com. And to follow all the links, head on over to hackaday.com/podcast. And until next week,
keep on hacking. Do I sound lower than usual?
who knows what I got the volume set to.
Why can't everything be normalized?
There, I'm done. Let me double check that. I will not say what I was going to say.
Did you think better of it, or are we just out of time?
We just got to get out of here. Alpha nerds.
Treat ourselves. Yeah, nah, that's good. That's good.
What the heck? It's happy birthday.
Leave me to read these things. I saw the headline. I'm ready to have my opinion.